In this lecture, we will cover random variables and discrete probability distributions. Before moving into random variables, we are going to look at some basics of probability that we need to understand before moving forward. So some probability basics. By definition, probability is a measure of how likely something is to happen. It's a numerical measurement of the likelihood of something happening. Many events can't be predicted with total certainty, so the best we can say is how likely they are to happen using the idea of probability. So if we look at this chart here, we have the events labeled above this horizontal line and the probabilities labeled below. The events are impossible events, an unlikely event, so it could happen but it's not likely to happen. Even chance means it's 50-50 chance of happening or not happening. Something that's likely is a little bit more likely to happen, and then something that is certain will definitely happen. So if we take a look at the under the horizontal line here, an impossible event has a probability measure of 0 because it can't possibly happen. And a certain event that is definitely going to happen, has a probability of 1. And in between 0 and 1 are all the other ranges of probability, from the unlikely events to the likely events. So the closer a number is to 0, it represents a more unlikely event. So for example, 0.05 is a probability that is unlikely, whereas if we get closer to 1, 0.95 for example, we have something that is more likely to happen. So it is a measure. Probability is a measure, a numerical measurement between 0 and 1, where numbers close to 0 are probabilities that are unlikely, while numbers close to 1 are probabilities that are likely to happen. We express probabilities as decimals between 0 and 1, or as fractions between 0% and 100%. So in this lecture, you're going to see both examples, as decimals and as percents. In general, let's suppose that we have an event and we are using the letter E to represent that event. And an event is the probability of it raining, for example. E would be raining. That would be the event. So P parentheses event E is the probability of this event happening. And by definition, this number is calculated with a fraction. In the numerator of the fraction, we have the total number of ways the event can occur, and in the denominator we have the total number of possible outcomes. So here are some examples of what that means. If we're looking at a die with 6 sides labeled 1 through 6, and we want to calculate the probability of rolling a 4 on a die, so this is the event, rolling a 4, the number of ways you can get a 4 is 1. There's only one number 4 on a 6-sided die, so there's only one way to get a 4, but there are a total number of 6 sides. That's a total number of possible outcomes, 6 on each face, and so the probability is 1 divided by 6, and if you do that, you'll see that on a calculator you are going to get a non-terminating decimal, and for the purposes of this course, we are going to round probabilities to 4 decimal places when expressed as a decimal, and then if we turn that into a percent, 16.67%, it's rounded to 2 decimal places. We try that again, changing the event so that the event is rolling an odd number on a die. Well, now the numerator changes because the number of ways this event can occur is 3. You have 3 odd numbers on a 6-sided die, 1, 3, and 5, so your numerator is 3. Your denominator stays as 6 because you're still rolling a 6-sided die and there are 6 outcomes that are possible, but 3 divided by 6 is 0.5 and expressed as a percent is 50%. If you think about coins, an event could be flipping heads on a coin flip. So the chance of flipping heads is 50%. Most people know that from common knowledge, but mathematically we calculate that by looking at the number of ways the event can occur, which is 1. There's only one head and one tail, but if we're interested in getting heads, then the numerator is 1 way of getting a head, and the denominator, total number of possible outcomes, are 2, because you have two sides to the coin. So 1 divided by 2, that is the fraction, equals 0.5 or 50%. So if you look at the probability of an event not happening, not occurring, we take the total number of possible outcomes minus the number of ways the event can occur divided by the total number of possible outcomes. And this is much more obvious when we look at examples. We decided before that the probability of rolling a 4 was calculated by taking 1 and dividing by 6. If we want the probability of not rolling a 4, we take the total number of possible outcomes, which is the same as the denominator, 6, subtract the one way we can get a 4, and what we're left with in the numerator is the number of ways of not getting a 4. So there are 5 ways of not getting a 4, and then divide that by the total number of possible outcomes. And on a calculator, again, you will see that this is a non-terminating decimal, and so we would get 0.8333 or 83.33%. Probability of not rolling an odd number, the same idea. Take the total number of outcomes, subtract the number of odds, and that leaves you with 3, which is the number of even numbers on a 6-sided die, and that is also 0.5 or 50%. So the probability of rolling an odd number and the probability of not rolling an odd number is the same, 50%. And the probability of not getting heads is the same as getting tails, and that would be 1 out of 2, 0.5 or 50%. Two concepts that we need to understand, especially as we approach word problems in this lecture: at most and less than. So let's suppose that we have a lot of candy gummy bears and we tell a child the following instructions. You can have at most 3 gummy bears. What are the possible number of gummy bears that this includes? So when you tell a child at most 3, it refers to the numbers 0, 1, 2, or 3. At most 3 includes the number 3. And when we're dealing with events, and these are going to be discrete numbers in this particular lecture, we're going to always start with 0, and we're going to go up to the number specified after the word at most and include that number. So that would be 0, 1, 2, or 3. Now if you tell a child you can have less than 3 gummy bears, the meaning of the phrase less than is different than at most, because less than does not include the number 3. So in this case, the possible number of gummy bears that satisfy that phrase would be 0, 1, or 2, because less than 3 does not include the number 3. So those two phrases are very important to understand and will show up in problems in this lecture and in this chapter. Similar to these two phrases, we have at least and more than. So if we have a high school student and we are giving the following instructions to the high school student, we can say, you must read at least 4 books before June. And what does that mean? What does at least 4 books mean? Well, when you say at least and you have a number attached to it, you mean to include the number 4, 4, 5, 6, etc. And it would go on. So at least 4 refers to 4, 5, 6, and more. So at least 4 includes the number 4. And if we change the words a little bit and we say you must read more than 2 books before June, it changes slightly because more than 2 does not include the number 2. It means 3, 4, 5, and more. So more than 2 does not include the number 2. So these are things that if is not immediately obvious to you, these are things that you should write down and refer to, because you are going to see these phrases in word problems often for the rest of this course, and you will get different answers if you use the wrong approach. If you solve a problem with a more than approach, but the problem requires an at least approach, you will get the wrong answer. So keep that in mind moving forward.